Welcome to the PolyWorks 2024 conference. Now, this year we're shaking things up with a brand new format. We're all about giving you the good stuff in just 60 minutes because we know your time is precious. Now, before we dive into our live interactive session where we'll explore the exciting new features of PolyWorks 2024, let's set the stage. Let's kickstart this conference with the president and co-founder of InnovMetric, Marc Soucy.
Hello, Anthony. Hello, everyone. Every year, I am motivated to participate in PolyWorks Conference live, particularly because I get to share my insights and observations about the evolution of digital 3D metrology processes with our customers.
All right, so Marc, what have you prepared for our attendees this year?
I want to talk about quality control teams creating value for their manufacturing organization. We believe that by leveraging the 3D measurement data, in other words, the PolyWorks inspection projects they create every day, quality control teams can not only make their own operations more efficient and productive, but they can also empower other teams, such as quality assurance, manufacturing, and product engineering, to achieve higher quality, efficiency, and innovation. Today, we will show how you can analyze and resolve dimensional issues that occur days, months, or even years after having measured manufactured products at a fraction of your current operating cost.
Okay, I'm interested. How can quality control teams empower other teams and their manufacturing organization to achieve this tour de force?
By retaining 3D measurement data and providing instantaneous access to this valuable source of information. In general, quality control teams know when and how the life cycle of their inspection project data begins. For example, the life cycle of 3D measurement data begins when measuring a piece, or the life cycle of a dimensional control could start in CAD software, when creating product manufacturing information attached to CAD geometry, or within PolyWorks Inspector when creating a feature and defining its controls. On the other end, quality control teams find it hard to proactively manage inspection projects at the end of the data lifecycle. For example, once a new product has gone into production, do you know what is done with the 3D measurement data used during the engineering and the pre-production processes? The inspection projects will simply be archived, and very few people will know where to find this information if and when they need to.
Okay, how about the 3D measurement data used to control quality during production?
This data will be used as a go, no-go tool to accept or not a manufactured product and compute trends and statistics to monitor quality, plan maintenance, and predict manufacturing issues. Once mathematical calculations are done, however, the raw data used to produce this information is generally only kept for a short period or directly sent to the trash can.
And why is this information not kept for a longer period?
Simple answer, lack of appropriate tools. Now, let's expand on that. Until recently, most manufacturers had not yet considered retaining 3D measurement data from production because they did not have the technological means to manage such a large amount of data. Where do we keep all that data? And in what form? I'm sure everyone viewing will agree, here's an extraordinary source of high-quality information that is captured at great cost, and everyone can benefit from it being stored and used as much as possible. This is where we can help with our PolyWorks Data Loop data management solution.
Okay, and how are you going to demonstrate the importance of retaining historical 3D measurement data to our audience?
First, let me tell you about one of the most famous rescue stories in history. 53 years ago, more than 200,000 miles away from Earth, that's about 330,000 kilometers, 3 astronauts were suddenly disturbed by a catastrophic explosion that shook their tiny spacecraft. NASA was forced to abort the Apollo 13 lunar mission and was scrambling to bring the astronauts back to Earth. With every minute that passed, the crippled spacecraft moved another 400 miles away from Earth. In the history of our species, no one had been in this much trouble so far away from home. The lunar module could be used as a lifeboat and had enough oxygen for the return trip, but an issue with the removal of carbon dioxide would have eventually killed the crew.
Okay, so a failing spacecraft 200,000 miles away, outside of direct human intervention. And the only way to save it was to diagnose a problem and solve it. Now, I'm sure our viewers are as curious as I am. Please tell us more.
Fortunately, NASA had access to identical twins of the lunar module, powered by a network of digital computers that were used to train astronauts and mission controllers in every aspect of the mission. Engineers on the ground were thus able to simulate the conditions of the crippled spacecraft and devise a crude carbon dioxide removal device by solely using material found on a twin. The crew was then sent instructions to recreate the same removal device on board their spaceship and successfully return to Earth. What might have been NASA's greatest disaster turned out to be its greatest triumph. So, when you're measuring a piece with a device like a laser scanner and storing it for future use, you are keeping a twin of that piece. The only difference is that this twin is digital in the form of 3D measurement data. And just like NASA, it can be used to plan the repair or replacement of a critical part in the defective product, improve future product designs, and protect companies from the financial risks of warranty claims.
Now, that's a good story and a great analogy. And now, will our viewers hear some examples on how retaining 3D measurement data helps?
Yes, of course. I will present 4 examples that illustrate the value of having access to the 3D measurement data after having delivered the traditional reports containing 3D measurement results.
Great. Okay, this sounds like a great program. I would like to tell our audience this is where you should have your pens and notepads handy to mark useful observations. And Marc, let's start off with our first example.
As humans, when we come across errors, we may be unsure of the path forwards. Imagine that you're an expert reviewing 3D measurement results and that you find an error or suspect the possibility of an error. How would you be able to confirm the existence of this error and fix it if you could not access the inspection project and the 3D measurement data? You wouldn't be able to do anything and would probably need to retrieve the physical piece and remeasure it. What a loss of time.
Okay. Well, let's look at an example on how retaining 3D measurement data allows you to fix costly mistakes, which some attendees may remember from last year's conference.
The manufacturing expert clicks the notification and quickly switches from the PolyWorks Data Loop web interface to PolyWorks Inspector to take a closer look at the inspection project. She reviews the datums used for alignment and realizes that her colleagues provided incorrect datums to the subcontractor. She creates a new alignment with the right datums. The deviation color map changes significantly, indicating that there is an issue with the first iteration of the new skin. The manufacturing expert accesses the inspection project's discussion thread and asks the project manager to schedule a meeting with the subcontractor to report the issue and plan the second iteration.
The jet manufacturer initially provided incorrect datums to the subcontractor, and when the expert reviewed the subcontractor's inspection project, he found the issue and updated the alignment, which produced completely different results and led to rework on the subcontractor's side. Would have the expert discovered the alignment issue easily if he had access to only the inspection results? His company would have found the issue at a later stage. And as a result, it surely would have been more expensive to fix it.
Okay, so our viewers can make a note that retaining 3D measurement data allows organizations to identify and repair mistakes.
Yes, and fixing mistakes helps reduce time to market and minimize production downtime.
There you go. Now, do you have another example of fixing issues?
Of course, the case where you need to dig deeper to identify an issue. My colleague Amar will show us how you can use historical 3D measurement data to perform a root cause analysis.
All right, let's watch this together.
We would like to propose a modern approach of using your 3D measurement data to directly enhance the root cause analysis process. Imagine this. An alarm for a failing dimension on a critical geometry goes off at the production line. The manufacturing team quickly involves the engineering and quality teams to help identify the source of the issue. Identifying the underlying cause or root cause of the dimensional issue empowers the analyst to solve the problem and to take steps to prevent it from happening again in the future. The quality team plays an essential role in the investigation process by providing insights obtained from dimensional inspections. However, the information available from inspection result tables and snapshots may not provide sufficient insights. Most often, quality needs to access archived inspection projects to gather additional information. This is where it gets tricky. With inspection projects inaccessible or scattered in many places on network folders and computer drives, locating and accessing the required information can be frustrating. It's like finding your way through a maze with the clock ticking. When production is stopped, every minute counts. Also, time-consuming manipulations are required to obtain dimensional insights beyond what is directly available from individual inspection reports and related statistics. You can imagine how complicated it can be to generate new Excel or PDF inspection reports when adding new dimensions to an inspection project, or when generating new inspection results with the context of different alignments and coordinate systems. Now, what if you could get a map to navigate that maze of data? Or better yet, be guided on a direct path to rich data insights. Today, you're already using PolyWorks to create 3D measurement data. How about we leverage all that data by storing it in a way it can be accessed seamlessly? This is what PolyWorks Data Loop helps you to do. This is the modern approach. In PolyWorks Data Loop, we don't simply store archived files. Rather, we seamlessly access full projects utilizing all the measurement data that you have created. It has diagnostic tools inbuilt using the powerhouse of data analytics that assist you to crunch all the data. For example, a tool that quickly helps you find which factor is affecting the dimensional failure the most. Simply choose how many parts you want to investigate and what factors you want to study, like machine, production line, shift number, and so on. PolyWorks Data Loop analyzes all the information available in your centralized data and gives you the results. You get a quick summary of which factors influence the dimensional failure. It gives your team a clear direction to orient the root cause analysis based on information from a dataset of all your inspections from maybe a week ago or months or even years. In a similar way, another diagnostic tool helps to compute the variability of deviation in a batch of parts. It's the same simple approach. Choose the number of parts, select the properties you want to investigate, and hit Analyze. You quickly get a glimpse of trends and statistical information that can help the manufacturing team get a quick start. And because you access the full treasure of 3D measurement data, it's easy to dive deeper from a broad summary level to a piece property detail to investigate further. Since you have access to the complete project, it's easy to add some dimensions or edit some parameters, propagate those changes across all the parts, and analyze the impact of these changes. having a centrally stored digital twin gives you that benefit. Without the digital twin, it wouldn't even be possible to imagine this. You can also see the importance of metadata, the properties of each part. All the part information like the part name, the project name, shift number, machine name, etc. that was stored during the initial inspection continues to help you investigate better. More information the parts carry, the deeper the analytics you can get. Your daily inspection work has more importance than one would think. Finally, when the computations are done, PolyWorks Data Loop presents results in tables, columns, and visual 3D, which leads to a clearer understanding of results, and that can help you better find the root cause of the issue. One half of the solution is already with you. The PolyWorks inspection project are yours. It's your data. The next half of the solution is to save it centrally in a digital data management system. Add all the relevant properties on each piece, and you're just one step away from using it all to give you data-driven insights, right at the beginning of the root cause analysis process. Choosing this modern approach helps you to collaborate with engineering teams when they have an emergency or whenever they need dimensional insights for more informed decision making.
Okay, now for our viewers, can you expand on the benefits of being able to perform root cause analysis the way you propose?
Well, there are 3 benefits. Firstly, speed. You don't have to find the physical pieces or measure them again. Just a few seconds and you're ready to work. Secondly, ease of access. The physical pieces you want to analyze might be located in a warehouse, in a shipment, or even already delivered to a customer. You don't have to be burdened with that if you have access to the scan data. And finally, convenience. It would be impractical to remeasure 50 or 100 pieces, but if you retained the scan data of these pieces, you could analyze a batch of pieces and get the additional statistics and trends you need to find the root cause of an issue. A manufacturing organization that retains the scan data of its manufactured products could leverage this information to prevent a costly recall or perform a speedy repair on a shipped product.
All right, this almost sounds like an insurance policy. Retain your 3D measurement data in case you need it. And if you ever need it, there is a high probability that you will save significant costs.
Wow, that's a great analogy. You're getting the idea.
Okay. Are there any other uses for 3D measurement data once the measured piece is long gone?
Yes. Remember the lunar module twin from the Apollo 13 story? With the scan digital twin, you can simulate the behavior of a fabricated piece under various physical conditions or analyze the mechanical interactions between a fabricated piece and its mating parts.
Okay. So if I understand correctly, having a digital twin is like having the physical piece in front of you.
Exactly. Many people in the manufacturing community have been dreaming about the possibilities offered by digital twins. But until recently, the concept was not scalable and could not be applied to the output of entire production lines. Fortunately, this is no longer the case, thanks to the advent of the PolyWorks Data Loop data management solution. Let's hear from Joshua Mickelson, Senior Quality Engineering Manager, and Matthew Leonards, Quality Expert at Bobcat, an American-based manufacturer of farm and construction equipment, on how they intend to leverage digital twins and historical 3D measurement data.
All right, let's all watch this together.
So we don't save our data to just save data. We want to make decisions off of that data.
You can use historical data to evaluate your tolerancing and GD&T, your geometric dimensioning and tolerancing schemes for a specific part, and you can take that historical data set and you can test out new data reference frames and feature control frames to see whether or not those are good feature controls to use for a given type of geometry, for example, or a given product type or structure.
Warranty data, warranty trends, those type of data, we evaluate those against what our factory actually produces, and we actually will change next generation product manufacturing processes. I can create a feature or a characteristic today, and I can retroact that against my archive data and actually figure out what was going on then, even though I didn't technically measure that part there. I have the ability to do it.
In the future, I foresee model-based definition becoming a huge thing in this industry, and we will need an awful lot of data to back up some decisions.
We've really kept that data lifecycle management portion a part of our organization so that we can make the right decisions and have the data readily available whenever we need to make decisions on it.
All right. Thanks, Joshua and Matthew, for sharing Bobcat's proactive approach to leveraging their historical 3D measurement data.
Historical data is essential to allow design engineers to evolve their tolerancing and GD&T dimensional control strategies. As the design team can now easily access real data from models in production, new inspection strategies can now be tested and improved before deploying them in the field.
Wonderful. Mark, what's your next example showing the value of retaining 3D measurement data?
We have Carl Huckabee, capability lead at Rolls-Royce Aerospace. He will explain why his company intends to retain detailed scans of the aircraft engine components they make.
Let's listen to this story right away.
Rolls-Royce take quality and product safety very seriously. We work in highly regulated environments where historic data is very useful to us. It just generally helps with how we manufacture parts. There's lots of complex processes, and we go back and dig into that data to find issues and fix them. Storing metrology data helps us to understand some basic concepts, things that sound quite simple, but in a large organization across a worldwide network are really difficult sometimes. So, is gauge A better than gauge B? Is the tolerance wider on that engine type than this engine type? How much scrap do we make? And how do we retain our quality? There's one specific example where we've used historical data in turbine blade manufacture. We took many scans from the CT machine, which we collected over the period of a few months, and then started to change the way we interpret that data, use a different datum system. In the aerospace industry, we always try to balance the high resolution, day-to-day data with the long-term certification requirements. Retention can be for life cycle of product plus 10 years. So some of these data sets from some of these engines here have been around for 60 years.
Thank you, Carl, for sharing how you invest to mitigate future issues. Mark, anything else you'd like to add?
Yes, I'd like to add an additional reason to start retaining and managing your 3D measurement data now: AI technology. We have all heard about ChatGPT and the feats of deep learning technologies with natural language and image recognition tasks. When used with human supervision and governance, this type of technology can deliver precious help and advice. For example, it can detect performance issues, provide insights to optimize processes and make smarter decisions, understand how and when failures and breakdowns are likely to occur, and much more. It's one thing to understand the potential value AI can have in manufacturing. It's another to actually implement it. Do you know how much data is required to create and train AI models? Millions of dimensions would be a starting point, with the objective of reaching billions.
Okay, and how can quality control teams contribute to the implementation of AI in their organizations?
Our friends from the quality control teams are at the start of an important evolution. The work they do every day is creating tremendous value, and the 3D measurement information they collect today will be leveraged for far more than its initial use, provided they are kept in a place and form that makes it usable. Imagine the future we can build by being able to build a centralized repository that allows storing the large volume and large variety of 3D measurement data required to build reliable AI models. Store data with all its meaningful properties, which we call metadata. You see, metadata plays a critical role in the process used to train AI models. It sets a context that allows the system to accurately process, categorize, and analyze information. And finally, set up a steady stream of new data, a pipeline of your completed inspections and dimensional analysis to feed and help iteratively improve AI models. That image of the future looks very exciting, and we are with our customers to help build it together.
Now, this is certainly an eye-opening example. What should attendees retain from all these insights?
Companies today are saving their inspection projects on PolyWorks Data Loop to be able to perform root cause analysis rapidly, set up alarms to detect dimensions trending out of tolerance, and to facilitate communication between stakeholders. Holding on to that data so that you can meet unexpected challenges with delivered products, accelerate future designs, and profit from the evolutions that AI can propose by studying historical data is a natural progression in discovering the true value and benefits of your 3D measurement data. It was a pleasure for me to share these insights with you. If you were inspired by these examples, do not hesitate to reach out to our team. We have all the solutions available today and at an affordable price to empower manufacturers of every size to benefit from the incredible value that can be created by leveraging their 3D measurement data. Thank you very much for listening.
And thank you, Marc, for sharing with the PolyWorks community.
You're welcome.
All right. Now let's continue with the live session showcasing the new features of PolyWorks 2024.